mic?
Both an honor and a pleasure to introduce Matt Jackson, who's the William Eberly Professor of Economics at Stanford University. It's an honor and a pleasure because Matt is a wonderful person. It's hard to think of people, economists at least whom I know, who are as uniformly liked as Matt is. He's also a spectacular academic economist. He's an exceptional person in many dimensions. I won't go outside the academia. I don't know him well enough. But, there are dimensions which I do know which are just exceptional. But within academia, he's going to be teaching, I just learned this, he's going to be teaching a course with more students than most of us, even combined, will teach in our lifetimes. He's going to be teaching an online course with, for which so far 40,000 students are registered. And maybe after this lecture, he'll have a few more. He is on the board of, has been on the board of a variety of journals as an editor and co-editor, and including Games in Economic Behavior and Econometrica, two journals many of us really like. He's made important contributions in an endless list of fields and theories, so I won't start listing them, so that Matt can have a turn. But among them, he's made critical... basically brought to the forefront of economics research today, and he's going to be talking about that. He's also unique in the span of the type of work. He's done purely abstract work on topics like epsilon equilibria and duality, and he's done extremely, what I would call, hopefully not insulting anybody, extremely down-to-earth economics about studying fire insurance in Andorra and microfinance in India. And in fact, today's talk clearly indicates that span that Matt uniquely has. And he's going to be talking, as it says, about networked interactions and economic behavior, lessons from rural India. Thank you, Matt, for agreeing to give us this talk.
First of all, thank you to Eddie for that very gracious and kind introduction. So it's a great pleasure to be here, and just in terms of putting this in some perspective, I wanted to start with a quote from Elisha Pazner, and this comes out of David Schmeidler's introduction to the Hurwitz, Schmeidler, and Sonnenschein volume that says it matters not only what you get, but how you get it. And today we'll be talking a bit about it's not only what you know, but who you know, which I guess is sort of the antecedent to this quote. So really understanding connections and information. And it's just by ways of a personal connection. I never had the pleasure of meeting Elisha Pazner, but some of his work, and in particular this volume, was one of the first ones that I ever purchased as an academic, and one that I read cover to cover many times. So it's an honor and privilege to be here. So in terms of the topic today, I've been working in the area of understanding how social interactions impact economic behavior for a while now. And in particular, I want to sort of focus on two different aspects of that. One is that when we think about economic interactions and the way that people behave, most situations where we are learning information or transacting, those are ones in which we have certain patterns of interaction. So when we think about things like getting access to information about jobs, that often comes by word of mouth from friends or acquaintances. When we think about new products, today we'll talk a little bit about microfinance. We might learn about that from our friends and acquaintances. Sharing of favors or risks, so whether you get personal loans not from a bank but from somebody in your family or friends. Transmission of viruses, opinions, investments in education, how we view the world and whether we think education is a valuable thing to invest in. All these things are shaped by our social context. And so understanding that social context is really fundamental to understanding the economic behavior. So that's one direction. And I think that that's a really important direction to understand and to have incorporated into economics. And then there's another direction which this moves in, which is that economic theory actually provides us with some useful tools and ways of thinking that help elucidate the social connections. And so I want to spend a little time today also talking about how economic modeling can help us understand social interactions in ways that we wouldn't understand it without those models. And in particular, by using economic models, we can help disentangle data that can be very hard to parse otherwise. So actually having some particular models in mind of what might be going on helps us to understand the data. And understanding incentives in particular is something that economic modeling is particularly well suited for, and that'll help us predict social structure. So there'll be a couple of themes there, and in particular in terms of what we're going to spend time on today, one will be understanding social structure for new products, microfinance. We'll spend a little time talking about sharing of favors and risk, and then we'll look at using models to help us analyze the data, and then also understanding incentives and what that says about social structure. So we'll pick off a few pieces of this bigger picture just in terms of illustration today. Okay, so in terms of outlines, what I'm basically going to do is go through three different examples of situations where social networks are important in understanding behavior and where models can help elucidate the social structure. So the first one we'll start with is social networks affecting economic decisions, and in particular this is going to be people's decision of whether or not to participate in a microfinance program. The second will be economic modeling helping us to understand the network diffusion process. So these will be from the same data, but looking at how the economic models might help us here. And then the third will be understanding network patterns of favor exchange. Okay, so we'll start with this first one. And what I'm going to do is take you through a project that I've been working on, I guess now for a little over 3 years, with Abhijit Banerjee, Esther Duflo, and Arun Chandrasekhar. And this is a situation where what we did is we had access to a series of villages, rural villages in southern India. So in particular, we'll talk about 43 of those villages today. And we looked at a situation where these villages are fairly isolated, fairly poor, and there was no access to external finance before a bank came in and started offering a loan program. And there was a question of whether or not people in these villages would participate in the loan program. So what we have is we track the adoption of microfinance in these villages, and the participation rates in the villages, so there are certain people that are eligible. Basically, the eligible people in these villages are women between the ages of 18 and 57 years old. They have to meet some particular requirements. But out of the eligible populations, in some villages you saw 7% of the population participate. In other villages you see 44% of the eligible population participate. So there's an enormous variation across the village in whether or not people end up taking up microfinance. And we might want to understand why. So why is it that they're offered the same product? When you look at the villages, there's some differences in demographics, not tremendous ones. Can we understand exactly why it's taking off in one village and not taking off in another village? Okay? So where do these different rates come from? Okay, so the nice thing is that the data set is fairly unique in some ways. So the nice thing about the data is that when we look at diffusion studies and we're trying to understand how diffusion occurs, you often are dealing with a single network or a single, you look at whether or not a new movie takes off in a market or so forth. Here we have sort of 43 isolated villages, and we can do comparative analyses across what the villages look like. So we have many different networks, many different villages, and coupling this together with the economic behavior here over time is a data set that you don't see in other applications. So Most often you see nice network data without time series of behaviors, or you see some nice time series of behavior without necessarily having social structure, or you see maybe them coupled together in one data set. But here we have, the nice part is we have a whole series of different villages and the same thing going on in each one over time. And that combination is going to allow us to identify how social structure impacts the decisions that are going through here. Okay, so just to fix the geography here, so all of the villages are in an area of Karnataka, for the southern part of Karnataka, which is all within about 100 kilometers of Bangalore. So this is rural southern India. The villages are on average about 1,000 people each. And I can show you the kinds of data that we've gotten. So this is one of the villages. This is a network, so we went into the villages and we surveyed all the individuals in the village. Well, not all, but we did a sampling. We have different villages, we have different participation rates, but we have fairly detailed information about the households. So here, for instance, is one of the villages, and in particular, these small dots that are agglomerated into nodes here are people within a household. So you've got a household of 2 individuals here, a household of 4 individuals, 10 individuals, and so forth. And we asked them a whole series of different questions. So this network is, if you needed to borrow 100 rupees for a day, who would you go to in order to borrow that? In terms of the per capita income, it's on the order of 100 to 200 rupees per capita a day. So if you're asking, if you had to borrow a day's wages, who would you go to borrow from? So these are the answers to those questions. So we end up with a network of relationships. So each household we can track who would they borrow from if they needed rupees per a day. Here's who do you go to temple with? So we ask individuals who they end up going to religious services with. Obviously, this is not a terribly religious village as far as they go. Here's one. Who do you ask for advice? So we've got advice network. Who comes to you to borrow kerosene? Who do you go to borrow kerosene? Who do you borrow rice from? Who do you go to for medical help? So we have a whole series of different questions, and piecing these all together, then we end up with networks of interactions, so we know who would be likely to talk to other people on a given day-to-day basis. Okay, so that's some of the background information. What other data do we have? So then we have the microfinance participation. So the bank came into these villages, offers the loans, and we have loans over time. So we can track who's participating in the loan programs over time. We have the number of households in the village, what's their composition, the age, gender, subcaste, religion, profession, education level, who their relatives are. We have wealth variables that are, what type of latrine does the house have, what's the number of rooms do they have, what kind of roof do they have, do they participate in what are called self-help groups, which are ways in which you can share risk and do some minor banking, ration cards, voting, various caste information. So what fraction of the village is in what you might call higher castes, so forward castes or otherwise backward castes, rather than scheduled castes and scheduled tribes. So there's a series of different background information that we have, demographics from the census of the villages, then plus this network information, and then the banks come in, offer microfinance, and we can track who participates over time. Okay, so obviously when you look back at these networks, they're actually fairly complicated objects. So having a mapping, so what we'd like to have is a theory of how does the social structure impact behavior. Well, the first thing we have to deal with is how do we describe one of these objects, right? So one of these objects is fairly complicated, so we need to distill it into some fairly simple language. And just as in terms of motivation, what's the usual challenge in working with networks? Let's just ask the question, how many networks are there on 20 nodes? Suppose we just had a village of 20 people. What's the number of potential different networks that you could draw on that village? Well, person 1 could have 19 possible friendships, right? So person 2 could have 18, not counting the friendship that we already counted with person 1, and so forth. So if you go through, just in terms of the combinatorics, there's a total of 190 possible paired friendships in a group of 20 people, right? So then, out of 120 possible friendship links, each could either be present or not, right? So you could turn each one on or off. And you begin to do that, what do you end up with? How many networks are there on 20 nodes? There's 2 to the 190th possible networks if we're not counting intensity or anything else, just counting whether there's a link present or not, right? How many atoms are there in the universe? I got these numbers from Wikipedia, so I don't know how accurate they are, but you can get estimates anywhere from 2 to the 158th to 2 to the 146th. 2 to the 246. So, roughly what we're getting is the number of networks, just even with 20 nodes, is quite large. So what we're going to have to do is abstract away from the full generality in order to try and describe these and work with them. So in terms of understanding networks' impact on diffusion, what we can do is just distill the network down to a few important characteristics. And the three main ways in which we might break down a network to keep track of essential ingredients will be, one, just connectivity of density. So how densely connected is the network? How many friendships do people have on average? Second, we might keep track of segregation patterns. So are there certain groups that don't talk to other groups? So for instance, in the Indian villages, when you look across caste, you'll see fewer ties across caste than within caste. And you'll also see religious breaks and other kinds of things. So you'll see patterns in the network that are divisive based on characteristics of the people. And you'll also see local patterns, and I'll talk about that in some detail. So let's just try to figure out, if we're trying to think about why one village might take up microfinance more than another, what hypotheses might we entertain in terms of whether or not there's really a social component to this. So I'll start with connectivity and density. And let's think, so what I did here is just look at 2 different networks. So suppose we had 2 networks, one with fairly low density and one with higher density. Okay, so we compare 2 different networks, and then we think about a diffusion process on that. So how would a diffusion process work? Well, we could start by telling, say, 4 people in this village and 4 people in this village about availability of microfinance. So we start by seeding the network with a few individuals who are aware of this product, and then we see what happens. Okay. So tell 4 people here, tell 4 people here, and now let's suppose that each one of them tells half their friends. Right? Well, obviously in this village we're going to get not as many people told. These individuals don't even have friends. The other individuals might tell half of their friends. If you begin to look at this diffusion process, just by simple word of communication, this one is eventually going to lead to much higher participation rates than the other one. Right? So very fundamental, basic observation is just put in more relationships, you have more opportunities to communicate, things are going to diffuse possibly faster and more extensively. So hypothesis 1, we'll just keep in the background, higher network density should lead to higher participation rates. And you can find this in all kinds of different diffusion processes. There's a series of papers that make this statement more rigorous. I won't go into it. I mean, it's a fairly obvious statement, but it depends on the particulars of the process. Okay, so that's one thing to keep in mind. Density is going to matter. Now let's think a little bit about segregation patterns. So they should matter as well. How might they matter? In terms of understanding segregation, there's a term that's known as homophily, which comes out of the sociology literature. And it basically it was a term coined by Lazarsfeld and Merton in the 1950s. And it refers to the fact that people tend to associate more with other individuals who have similar characteristics to themselves right? So birds of a feather flock together. It's typical of most social interaction as well as many economic ones. The sociology literature is very extensive on this, so it's been documented in terms of age, race, gender, religion, profession. Pretty much any dimension you can imagine will exhibit some of this. So just in terms of some pictures, to give you an idea of homophily, this is one example. This is pulled from a paper I wrote with Sergio Cuarini and Paulo Pin. And what this is this is actually a U.S. high school. It's a high school of 255 students. So each one of these nodes is a student. And there's a link between two students. They actually engage in at least 3 activities per week with another student. So this is self-reported activities. They were interviewed and asked, do you study with so-and-so? Do you have lunch with this person? Do you hang out after school? There's a whole series of questions. And so a link is present if 2 individuals have a relationship in terms of doing these activities together. The nodes here are colored by race. So self-reported race. The blue nodes are blacks. The red nodes are Hispanic. Yellow are whites. And then there's some others and a few missing. But basically, the important thing to notice here is obviously there's a strong segregation in terms of the friendship relationships, right? So even though it's a fairly integrated school in terms of the composition of the races, here you see, in fact, only 3 relationships between whites and blacks in the whole school. So you begin to see that this kind of segregation pattern can obviously affect the diffusion process. If you are thinking about what's the probability of something that's going to transmit across race, you're going to get much lower transmission in this kind of network than one that might have denser connections across the groups. Just in order to give you some ideas of other applications where this has been studied, this is from a paper by Lada Adama and Glantz. These are actually political blogs in the 2004 U.S. election, and they're colored by political affiliation, and there's links in situations where one blog actually refers to another blog. And actually, so they're done by Democrat and Republican, and the yellow ones are ones that go across blogs, and in fact, most of the ones that go across blogs, if you code these as positives or negatives, most of the ones that go across tend to be negative comments. But you see again, some sort of separation. So the important thing about understanding what the implications of segregation patterns are going to be for the behavior, then, are fairly straightforward. But again, I just wanted to sort of make sure the picture is fairly clear here. So let's think of 2 different types of nodes, say green nodes and yellow nodes, and think of, so we've got a lot of homophily. The yellow nodes tend to be linked to yellow nodes, greens to greens. And then we start a process here. So let's suppose that we started a microfinance diffusion here where we seed the village with 2 individuals who are willing to take up microfinance, and suppose that individuals care about whether they know other people who are doing the same, right? So we think of, I participate in microfinance if at least half my neighbors do. So you begin with 2 initial participants. Well, this person now has half their neighbors participating. We're going to have that person be willing to participate, right? So they join into microfinance. Now this person has 2/3 of their neighbors participating, and this person has half. So we get 2 more participants, and then this person participates. So if we had this kind of segregation pattern, we would begin to get participation in the yellows, but here it might not jump over to the greens, right? So depending on what this process is, you could imagine that the process stops short of going through the whole network because of the segregation pattern. And so the segregation pattern is going to be important again in understanding whether or not we get diffusion. So just keeping that in mind, another hypothesis would be that higher homophily, so more segregation in the network, stronger cuts in the network, should lead to lower participation rates. And there's a nice paper by Stephen Morris that has some measures of this. I've done some work with Ben Golub on learning speed of communication processes when there's homophily. So again, higher homophily is generally going to lead to some sort of disruption of diffusion processes. Okay, so 2 hypotheses about 1, general connectivity, 2, about segregation patterns. Let's also think about what we say about local patterns of seeding of microfinance and how that might work. So how central or important are certain nodes? And in particular, in these villages, so in approaching the villages, there's limited communication. So it's very difficult to get word out to villagers about a new program. So in going into the village, what the bank did was they had a list. They would tell their employees, here's a list of 10 types of people that you should try and find in the village, and tell them that we're going to be back and we'll be offering microfinance loans. So in particular, look for a shopkeeper, look for a school teacher, look for somebody in a municipal government, so look for a religious leader. So they would have a list of, here's a list of people to look for, find those people, and then tell them, here's what we're doing, we're coming, we're going to offer loans, we'll be back in 2 weeks, tell your friends, and so forth. So does the centrality, in some sense, of these initial injection or infection points matter? So if you think about it, starting a process of diffusion, we're picking initial points to first inform. How does that affect the overall diffusion? Okay, so let's think about how we might capture something like centrality. So one possibility, and the most obvious one, is just count how many people a given node knows. So this person knows 7, these people know 1. In this, you could say that this person is the most central person, right? They have a higher degree, obviously. Slightly more complicated network, you just count the connections, and we could say, okay, this is the most central person in this network. Okay, so we're just counting number of connections. More connections means I can reach more people, and that would be an idea that should lead to higher diffusion. Okay, so this is what's known, the number of connections in a network that a node has is known as degree. This is known as degree centrality. And if we start thinking about centrality and diffusion, obviously if you're telling friends with some probability about microfinance, then picking somebody that's more central can lead to more diffusion than if you're picking somebody who's more peripheral. So again, fairly simple idea, and that leads us to another hypothesis. If the initially contacted points have higher degree centrality, then there should be higher participation. And there's a long list of papers in sociology that work along this. The first is Katz and Lazarsfeld's study of opinion leaders in the 1950s. There's a study of the diffusion of tetracycline in 1966 by Coleman, Katz, and Menzel. So there's a series of different studies that have gone along these lines, which basically just say more connected people lead to higher diffusion. Okay. Okay. So there's a problem with this, and what's the problem with this kind of reasoning? Let's look at this network here and look at 2 different individuals. So this individual here has 2 friends. This individual here has 2 friends. Obviously, these 2 individuals are not the same in terms of how central they are in a network. And what we'd like to be able to do is capture the idea that some individuals are more central, not just because they have different numbers of friends, but because their friends are somehow better placed than somebody else's friends, right? So we want a notion that captures this idea that you're not only central because you have more friends, but you have better placed friends. Okay? The difficulty with this is now this becomes self-referential, right? So I'd like somebody's important because they have important friends, and their friends are important because they have important friends, and so forth. So another notion of centrality is one where what we do is we'd say that people are, their centrality is proportional to their neighbor's centrality, to the sum of their neighbor's centrality. So if I want to say that what's the centrality of a given node, I'm going to say that that's going to be proportional to the sum of whoever their friends are, the centrality of those friends. The nice thing mathematically about this, so more connections matter, but also it's accounting for how central they are, right? So we'll keep track of both of those things. In terms of the algebra, this is quite simple. We've got now that the centrality of node I is proportional to, if we keep track of a matrix, which says, is I connected to J? So this is 1 if I and J are connected, 0 if not. So we're just going to sum over the friends of I, their centrality. This becomes a nice matrix multiplication, and what we're looking for is an eigenvector of the adjacency matrix. Okay, so it's just the largest, the eigenvector associated with the largest eigenvalue of this matrix will be non-negative, and that's effectively what's known as eigenvector centrality. So this is a very nicely understood object mathematically, and it gives us a notion of how central nodes are. Okay, so we're just trying to calculate how central somebody is by looking at how central their friends are. Actually, just going back to this picture, if we calculate the eigenvector centrality of these nodes, what do we end up with? This one now gets 0.31, this one gets 0.11. So there's a dramatic difference in how central they are, which captures not just the number of friends they have, but how important their friends are. And in particular, you can see that this person's getting 0.31 because they're connected to a 0.5 and a 0.39, and so forth. So all of it fits together very nicely. These calculations can be done, approximated fairly efficiently for large networks. And so this gives us a more complete picture of what we might expect to be the important ways of disseminating something in a diffusion process. Just in terms of this centrality measure, it's very interesting that if you look at the algorithm behind how Google PageRanks were noted, so trying to figure out what's the importance of a given web page, the score of a page was basically devised to be proportional to the sum of the scores of pages linked to it. So if you wanted to figure out how important a page was and whether or not it should show up when you do a search for a certain term, you'd rank pages by how important they were. Well, how do you measure how important they are? By how important the pages that look to them are. So it's actually the early versions of Google PageRank. Interestingly, I don't know if you've, page refers to Larry Page, not the web page. So PageRank, the genius part about the way that they devised the algorithm was that they used eigenvector centrality more or less as the early algorithm. They had to adjust it over time because people figured out that they were using eigenvector centrality, and you can begin to manipulate that. But that's a whole other story. So the algorithm has become more sophisticated, but the basic premise behind it is more or less this. And this goes along with what's known as the random surfer model. So if you do the following kind of exercise, suppose you just go from a given node and you randomly transition to its neighbors. So you just think about a process which bounces around this network randomly. So each time you're at a node, you randomly pick a neighbor and you move to it. And then you randomly pick a neighbor, you move back. Here you move here. You could bounce around this network, each time randomly picking a link to move to. The eigenvector centrality numbers actually tell you what percentage of time you would spend at each node. If you have to figure out the percentage time spent at each node, that's effectively the same as how important these are in these measures. So it has nice intuitions and nice mathematical properties, and that's going to be important in diffusion because it'll tell us sort of what's the probability of information moving from node to node. If you start here, then you can reach very important nodes that can disseminate things to other nodes. Okay, so hypothesis 4, if initial contacted points have higher eigenvector centrality, then there should be higher participation in a village. Okay. Interestingly, what I've just told you about, there's very little theory on this. So there's one paper by Ballister, Calvo-Almengar, and Zanu in econometrics about 5 years ago that has eigenvector centrality-like measures in a game on a network. But there's very little that I know of that's been done on diffusion processes and understanding the initial points in this. But I think a reasonable hypothesis to throw in here is if initial contacted points have higher eigenvector centrality, then there should be higher participation. Okay? So what have we got? We've got 4 hypotheses here about how a network structure should impact the diffusion of microfinance. And then we can go to the data that we have and see whether these bear out. So are the villages with denser networks, should they have higher participation? So actually, when you look at the data, the density of the friendship networks, the most dense village compared to the least dense village is almost a factor of 2 in terms of the number of connections. So you've got a fairly wide set of variation across villages. Homophily, you see substantial homophily in these villages. It varies from about by a factor of about a half across villages. Higher degree centrality, we see, I'll show you some pictures of the variation here. So we can look across the different villages and see how that correlates with the actual participation. Okay? So let's take a look at that. So first I'll just show you a regression of microfinance participation against number of households per village, average number of links per household, and a homophily measure. And I won't go into explaining exactly what the homophily measure is, but it's a measure which approaches 1 if you've got a complete cut segregation, and it goes to 0 if things are evenly randomly distributed. So it's a 0-1 measure that picks up how segregated the strongest cut in the network is. What do you end up with? So first of all, an aside on methodology here. So obviously the networks are endowed objects. So people are choosing these relationships. So they could be correlated with other kinds of things that matter in microfinance diffusion. So we spend a lot of time worrying about that and the endogeneity. I'm not going to go through the details of that here. But actually, even if you just do the crude regression of participation on these variables, the interesting thing is we're not finding significant relationships. So here, the 3 stars means that this is significant at the 99% level. So here we have standard errors in the parentheses. So the number of households in a village matters. So the larger the village, the less participation you get. That's simple, straightforward. Higher density, we're actually not seeing an effect, and actually it's even slightly negative if you look at the coefficient. The homophily measure, you do get a slight negative effect, but again, that's not statistically significant. So from the first set of hypotheses, it's not looking like the social structure variation in the number of links or the homophily is mattering much at all. Okay, so those first 2 hypotheses don't seem to matter much in these data. And part of the reason that it might not matter here is these villages are all reasonably densely connected. And so the variation, the picture I showed you at the beginning had a village that was not connected and another village that had a lot of links. And there you see a pretty stark difference. Here we're looking at villages where each household has roughly somewhere between 10 and 20 other households that they're connected to. And so it could be that the density is already past a threshold at which you get diffusion and you don't need to, so that the small variation here isn't mattering much. Okay, so what affects diffusion? So network structure, it's not mattering so far in any specific way other than size. So now let's look at these first contact points and see if that begins to answer why there's 7% in some villages and 44% in other villages. So how does the network position of these leaders that the bank first contacts matter in diffusion? So we have these 2 hypotheses. Villages where leaders have higher degree centrality, so if the leaders have more connections, that should lead to higher participation. And the villages where the leaders have higher eigenvector centrality should also have higher participation. And one thing that is nice about these data in terms of the econometrics of this is that the bank did not pick the leaders based on degree centrality or eigenvector centrality. They picked the leaders just by a list of looking for a school teacher, looking for a mayor, looking for a religious figure. So they had a certain list of criteria which provides independent variation from the actual centrality of these people. So in some villages it turns out that the school teacher is very central. In other villages the school teacher is not very central. And so then we can compare when they were the school teacher in one village where that happened to be a central person and one village where it wasn't, do we get very different reactions there? Okay? So the two things we're looking for then, how many connections and then whether this eigenvector measure begins to pick things up. So first of all, here's just a picture. Average degree of leaders, it goes from roughly 12 to about 27. Here's the participation rate of the villages going from about 7% to about 44%. No real relationship. I mean, actually, if anything, a slightly negative relationship if you put the best fit line to it, but that's not significant. So it doesn't look like the number of connections of the leaders is mattering much. Okay, so we've struck out on 3 of the hypotheses so far. So where do we go from here? We're left with the one that the eigenvector centrality might matter. So here's the picture of the average eigenvector centrality of the leaders. Here we're going from, again, the 7% participation up to 44%. If you look at this, then you get a positive and highly significant relationship. So in fact, you can put all these things together. You can put all the demographics. You can, you look at, put the various variables here. If you look at microfinance participation, put an eigenvector of the leader, degree of the leader, number of households. You can add whatever variables you want. This turns out to be significant and strongly positive. So basically, what do we conclude from this? Network structure isn't mattering so much, but the first contact points do matter. So we still learn a lot by looking at the network, and in particular, in this process, knowing what the eigenvector centrality of a given node is makes a big difference in predicting whether or not we end up getting a significant diffusion or not. And degree centrality doesn't seem to matter nearly as much. Okay, so we get to one thing that we learn out of this. One thing to say about this, there's still not so much theory that's known about exactly how the set of initial points works. So we have some evidence that this works, but it would be nice to have stronger theory behind some of that. Okay, so this was somewhat organic in the approach. So I just put up a series of hypotheses that were loosely motivated by various some background theory, and we just tested that directly with the data. So let's take a look more deeply at what's actually going on in this process and see whether or not if we instead use a structural model where we are very careful about modeling exactly what's going on, can we learn more about how this process works, so how we're getting diffusion here. So in particular, let's look at a few different questions. First of all, what determines behavior? So when a person is deciding whether or not to take up microfinance, there's at least 2 things that are going to matter. One is, are they informed or not? So just basic access to information. So in these villages, you don't have, very few people have telephones, televisions, etc. A lot of them don't read. So in order to get information, you have to have just been told by somebody. So how many people actually just even know that microfinance is available? And then secondly, we could imagine that there's some sort of complementarity or peer influence. So once I'm informed, then maybe I look to my friends and say, oh, are you participating? What do you think about it? Is it a good thing to do or a bad thing? Maybe I want to join together with my friends. Maybe I can borrow from my friends. There's all kinds of reasons that we might expect one person's decision to be linked to their neighbor's decision, right? So we could imagine that just information matters. We could imagine that people's decisions are based on what their friends are doing. Another question is one that doesn't appear in most of the epidemiology, sociology, math, physics literatures, and so forth that look at networks. Are non-participants important in diffusion? So often when people model diffusion processes, you model it as a contagion process. So if somebody gets the flu, then they can pass the flu to other people, and they can pass the flu to other people. But people that don't have the flu can't pass the flu, right? But when we actually think about economic decisions, you might hear about a product from somebody who doesn't actually own that product. So I might have heard about an iPhone from somebody that doesn't own an iPhone. So in economic communication, non-participants can communicate information as well as participants. So we might want to model communication explicitly by non-participants. And so we can go through a structural modeling of diffusion and behavior and begin to understand whether doing that can elucidate what's going on in terms of the process.
Slightly related to that, is there a notion of contagion of non-participation in the sense that I've heard about microfinance and I'm not going to take it up, and therefore my neighbors know that I'm not going to take it up. So you have two contagion waves going on.
Yeah, so, right. So effectively, it could be that. The way we'll model this is that once I've heard about microfinance, the way in which I'm going to make decisions is going to depend on the circle of people who I know also know about microfinance. And I can talk to the people who don't and the people who do, and then look at the combination of those and try and figure out, based on that. So the process can be fairly complicated. You can think of lots of models that you want to fit here that would begin to capture these interdependencies. Okay, so let's think about a very simple model now of behavior and information diffusion. So first thing we'll allow is that people talk to their friends and they can tell them about microfinance, and we allow them to have two different probabilities. So there'll be QN. If I didn't participate, I'll talk to neighbors with one probability. If I did participate, I might talk to neighbors with a different probability. Okay, so somebody who ends up participating might just want to tell more people than somebody who didn't participate, for instance. So the simple kind of model, one thing we know is we know exactly who the people that the bank first contacted are. So we have a list of every person that the bank talked to and told about microfinance. So we can go into the villages, we have the networks that we showed the pictures of before, and we can end up seeing exactly who the first contacts were. So maybe there's a school teacher who decided not to participate, a religious figure that decides to participate, so we know those first people. So now we can ask, there's a model where people who don't participate are going to tell their friends with some probability. People who participate tell their friends with a different probability. So let's move forward in time. People pass information. If this person passes with, say, a higher probability, then maybe they tell 3 friends. This person tells 1 friend about microfinance. So they happen to have one conversation. So now what we can do is these people all have heard about microfinance. They can decide whether or not they want to participate. So actually the bank went back into the villages on roughly every 2-week intervals and would sign new people up in these intervals. So we have a time series of when people would show up and first participate. So we can check then, do these people participate or not? So some of them maybe choose to participate, some choose not to participate. Now we repeat the process, so they can talk to their friends with a probability, right? So they tell some more people. Those people look around, and they're going to make decisions of whether or not to participate, and the process just keeps repeating itself. So a very simple diffusion process will allow for probabilities of information flowing through people who even are non-participants. Yes?
Regarding the methodology here, okay, the letter on the upper side decided not to participate, but
Right.
tells his neighbor.
Right.
Why the, I'm sorry, it's not ready.
This green one.
Okay,
Yeah.
I got it.
Yeah.
I'm colorblind.
Yeah. Yeah, I should pick different colors than red and green. Yes. Yeah.
Do you take into consideration the results of being involved in microfinance? Because if it's successful, you should be more willing
Right.
friends about it.
Yeah, so that's a very good point. So the loans that were offered here are loans that were offered for basically a one-year period on the initial loans. And this process of diffusion that we're looking at occurred over a series of a few months that were fairly early on in the process. So
We don't know the results.
So we don't know what's yet. We want into the survey and try to find out to what extent people's outcomes. So now we have second wave of data and we're keeping track of the outcomes as well, and then we can incorporate that into the decision making and see how that matters as well.
No, sorry.
Yeah.
Otherwise, the lower way.
This one.
Does it tell the lower neighbor?
Well, so here, the way that we're keeping track of this, people know each other. That doesn't necessarily mean that they talk to each other about microfinance. So I might have a friend who, this could be a person that I borrow kerosene from. It might be that I don't bump into that person over the next 2 weeks, and I just simply don't pass. So even though we have the network of all the people that I know, I might not interact with all those people. So we're viewing this as a random interaction, and the likelihood that I am to tell people depends on whether, maybe it's on my mind more, maybe we're talking about something else. There could be a whole series of reasons why the information gets passed or doesn't get passed. So we end up with new decisions and so forth. So then the second part, so we've got the diffusion part coming out of the different probabilities of passing. The second part now is, what's my choice given that I'm informed? And so what we'll do is, let's let P sub I be I's choice of whether or not to participate. So think of this as a probability that a person is in a given situation. What we'll do is we'll just fit a, what's known as a logistic function here. So we look at the log of the odds ratios. What's the log of the probability I participate to the probability I don't participate? And that'll depend on a bunch of characteristics. So remember, we have people's education, their income level, their profession, their caste, a whole series of variables that are very important in determining whether or not they really want to participate. But then we also have how many of their friends participate. So if I'm somebody who I've heard from 3 people and none of them participated, does that lead me to have a lower probability than somebody who has 3 friends who all participated? So we'll keep track of the fraction of people who informed me who participate, and we'll have a parameter here which it should be positive if there's a positive influence of my friends participating on me. It could be negative if there's a negative relationship. Right? So it could go in either direction. Okay, so that's the very simple model. Then we can go ahead and fit this to the data. So how do you estimate this? You simulate the model for a grid of parameters, right? So we can try a whole series of different values for Qn and Qp. So start with 0.1, 0.2, 0.3, 0.4, 0.5. Put in the numbers for each one of these. We know exactly what the initial points were in the villages. We know the network structure. So we just run a program watching the diffusion go on each village, and then have people make decisions based on this function best fitting these parameters. So pick parameters for each one of these. And we'll try and choose the parameters to best match the simulated data to the observed data. So it's basically a simulated version of a generalized method of moments approach. Okay, so we're just a very straightforward exercise in matching the data.
The data, you have the information transmission information or only the participation?
So we have the participation and not the information. So we don't actually see who talked to whom, and that's all inferred from the model. So the model will simulate the model, and then we get a simulated process, and then we try and see for each, what are the choices of these probabilities of passing that best end up matching the data.
And matching the dynamic sequence or just the ending infusion?
Yeah, so we've done it about 3 or 4 different ways now. So we've done a dynamic, the version I'm going to tell you about is one where what we did is we looked at means and variances of various participation and covariance matrices of participation rates. We have another one where we've done it in calendar, matching the dynamics of it. It doesn't seem to make much of a difference. It turns out to be very computer intensive to run these. So each one, doing one estimation takes about 3 weeks in terms of computer time, because you have 90,000 nodes in terms of the total number of nodes, and so it's actually fairly intensive. But we have managed to do some of the time series ones, and you get pretty much the same answer. So the good news is you get the same answer, it seems, regardless of how we fit the moments. Okay, so what do we get out? So here's the basic model. So suppose, first of all, we do the whole model, but we ignore peer effects. So we assumed that people didn't pay attention to their peers. What would we get? We get that the non-participants have about a 1 in 10 chance of passing information to a neighbor. Participants would have about a 50-50 chance of passing information to a neighbor. The difference between these is 0.4. It's statistically significant. All of these are statistically significant at about the 99% level. The standard errors we get from a bootstrapping technique that's fairly straightforward. Now, if you fit the same model, and now we allow people to, so remember this BP here is this variable here, which keeps track of, does my participation decision depend on how many of my friends have participated? When you go through that, you get a positive but insignificant number there. So there's not a strong effect that we're picking up in terms of peer effects. So when we start to separate out the information effect from the influence effect, it appears that there's a statistically important information passing going on. It appears that it's different based on whether you're participating or not. But then once we account for that, there's not a substantial effect that's coming in terms of whether my peers are participating or not. Okay, so network effects, significant information passing. Information passing depends on whether you participate. More likely if you participate. Slight complementarities, but insignificant. Right? Okay. So what to say about that? One thing that we can do now, once we have this kind of model, is we can do a counterfactual and say, let's suppose that we closed off the channel of non-participants in passing information. So we said that non-participants pass with probability 0, but we'll keep the participants only passing information. How much do the non-participants actually impact the eventual diffusion process? Right? So what we can do is with the model, with QN at 0.1, what do we end up with? The percentage of informed people is about 81%, 82%. The participation rate's about 20%. In the actual data, it's 20.5%, so it's almost right on. So you get the model when we allow the non-participants to pass information, most people end up being informed. About 20% of them end up taking up overall. If we force it to be 0, so we just say non-participants no longer can pass information, then the information rate would drop to about 57%, and the participation rate would drop to about a little less than 14%. So you're accounting for somewhere between a third and a half of the participation in the information is actually coming through non-participants if we believe the model. And this goes to sort of what the usefulness of the economic modeling is in going to these exercises. Is this is a question that you can ask once you've gone through this exercise and we can begin to at least get answers. It's not, we have to have the model to do this, but it's something that we can get that you couldn't get without this kind of approach of using the economic tools to understand the social process. Okay. So what do we see? Insignificant and slight complementarities, but limited peer influence. Information passing significantly and substantially in terms of the numbers, more likely if you participate. And non-participants still play a significant and a role of at least a third and up to a half if you're looking at the actual participation rate. So we do see some things by using these kinds of models. Okay. So we've taken through what have these examples shown us. The first one was just saying, what do we learn from social networks that helps us understand this economic process of whether people choose to participate or not? We saw the eigenvector centrality mattered significantly. The second, we can use this economic modeling to look at more detailed information about how the process works, and we see that it tells us something about the role of non-participants, and also separating out role of information passing from actual complementarities. I think just in a matter of time, I won't take you through this in much detail, but let me just talk through what the last example is. So one thing we're doing here is we're taking the social structure as fixed. And the social structure in these villages is something people choose to some extent with whom they're going to interact. And we can also use some economic modeling to begin to understand what those patterns look like. And so the last example, basically using the data we have here, we can look at who passes kerosene, who borrows kerosene from who borrows money from who borrows rice from whom. So we have these different favors that are granted back and forth. And we can understand a simple game theory model of what patterns we should see and whether or not we see those patterns in the data. So a third study that I did together with Tomas Rodriguez-Barraker and Xu Tan, who are both students at Stanford, we looked at these different types of favor exchanges, and then we looked at how a simple game theoretic model of favor exchange would predict that the network should look, and then try to match that up to the data. So you can go ahead and do that. I'll skip this. But basically what it does is it gives you a prediction. So just in terms of the theory, it gives you a prediction that when people are trying to exchange favors, having friends in common can be very important in making sure that the relationship works well. So in situations where you don't have enforceable contracts, having friends in common who can ostracize somebody if they're not performing really gives you a powerful way of ending up supporting favor exchange. So you should see, every time you see A and B exchanging favors, seeing somebody, a third party C present is something that's going to enhance that relationship. And then we go through the data, and basically roughly around 80 to 90% of the time that you see two people exchanging favors, they have a friend in common who's also exchanging favors with them and has this ability to ostracize. And then one last thing this is sort of a fascinating data set that I always enjoy looking at. So everything I've been talking about up till now is the data from these Indian villages. You can also look at many other data sets. This is one of 15th century Florence. So this is looking at the Medici, the Strozzi, the Guadagni, a series of the prominent families in Florence, and looking at their business and marriage interactions. And you can look at the predictions of these game theoretic models and try to see whether or not these relationships are supported in this way. And it turns out here that if you look at business relationships, every single time that there's a business relationship between two families, they have a family in common which either married to both of them or business dealings with both. So you never see a business relationship that's not supported in this way. And again, a very simple game theoretic model gives you this kind of prediction. So in these data, it's only 16 nodes, so it's hard to take too seriously. But you get the Cosimo de Medici actually writes fairly explicitly about arranging marriages to try and broker business deals. So they understood the importance of having these indirect connections as the Pucci's, yes. Again, not a very popular family. Yes, so they're a little bit left out. Okay, so just general points. I think, in terms of the general area here, and part of the reason I've been understanding networks is that, understanding social structure is important in understanding a lot of economic behaviors. And so having richer models of social structure can help us understand why things are working or not working in diffusion processes, or why we see certain patterns of favor exchange and so forth. So economic modeling helps us parse network effects. It can distinguish different kinds of information effects from pure influence. There's a series of things that we can learn from this kind of approach. So thank you very much. It's been a pleasure.
We have time for a couple of questions. Okay, one very far in the back. This is the first person to raise his hand.
You spoke maybe about relations between two people, and not so much about clubs or congregations and the optimal size and, say, frequency of the interactions amongst stuff. Is there a literature about this issue? Is being studied? Is that an issue? We have a new world of networks, Facebook and so on. I guess it's very popular.
Yes, so let me take the questions in order. So one is that all of the relationships that we looked at within here were bilateral, and the self-help are actually of individuals. And there is when you read some of the social capital literature, there's discussion of the importance of groups and groups in enforcing social norms of behavior and so forth. So there's a literature in that direction. There's not much that gives us predictions. So in terms of modeling of these things, I don't know of much that's really been good at having a model where you can keep track of different types of networks at this, multi-graphs. So there's mathematical objects which we know about, but actually translating those into modeling hasn't really occurred yet. The second question about the Facebook and other kinds of things, I think it's actually a fascinating time period to be looking at this kind of research for a number of reasons. One is that the availability of data has exploded with internet communications that we can keep track of, with telephone data and so forth. So actually having accurate data about who communicates with whom is much easier now than it was even a few decades ago. The second is that also changes the way that people communicate. And so it's not obvious what that does. So there's a whole series of very interesting questions that arise about the fact that we can communicate with people around the world fairly easily via Skype, via Facebook, via a whole series of different things. How does that change the nature of our relationships? How does it change the number of relationships, the intensity? Does it lead to increase in homophily or decreased homophily? So there's a whole series of interesting questions that I'd love to know the answer to, but we don't yet. So.
Yeah, I have a notice question. You're based on the eigenvector. The eigenvector is no meaning here?
The what? The eigenvalue? Yeah. Well, actually, the eigenvalue does have meaning, and it actually relates. So the homophily measure that I didn't tell you about is related to the eigenvalue. So if you look at a certain variation on the matrix, the eigenvalue tells you about how segregated the network is. So it's a useful object in itself. Yes.
If I have understood correctly, a node was a village, not the one who is eligible for the microfinance. So maybe, I'm just proposing, if you would take a sample of only of those who are eligible to the microfinance, maybe you could have got a more significant relationships.
Yes, so we have, so actually that's a very good point, and we have been looking at various structures of keeping track of eligible and non-eligible people. Because here, when we fit the participation decision, we fit that, I didn't go into the details, but we fit that separately for people who are eligible and not for the people who aren't eligible. So we do keep track of that. I didn't want to go into too much here. But it is important in understanding what the process looks like, indeed.
I would expect some kind of avalanche at some point, because like in a flu or something like that, beyond a certain point, becomes an epidemic. Did you find something like that?
Yeah, so there's actually, I guess in the diffusion literature, there's what's known as S-shaped adoption curves. So things accelerate up to some point. Eventually they have to slow down because you can't you've only got 100% of the population that can be infected. So here you do see, so when we have time series, it's hard to get exactly S-shapes precisely, but you do see initial some increases in, so the things start out fairly slowly and then pick up over time. So you can begin to look at that. There's a lot that I didn't talk about in terms of time series that you can use in terms of the data. One thing that does turn out to be interesting is eigenvector centrality. When you look over time, it's amplified. So the effect of how central a given individual was, the initial person who's contacted, when you look at their eigenvector centrality, that's a more important determinant of what the third time period. So you can keep track here. I'm just keeping track of, was it overall, how much did it matter? You can say, how much did it matter in the first wave? How much did it matter in the second wave? How much did it matter in the third wave? The further the wave is, the more important that number is in determining whether a village, so the time series actually does have that factor, and you get this kind of contagion avalanche effects, yes.
Thank you very much.
Thank you.